This simplified animation shows how uranium is extracted. This is the uranium ore, and it is extracted using a drill that pulls the reamer up through the pilot hole, widening it. The broken ore then falls into what is known as an extraction chamber. Next, a bulldozer, operated remotely to keep the operator at a safe distance from falling rock hazards, picks up the uranium rock. Fast forward, the uranium is then condensed, ground, and placed into a centrifuge for further enrichment. Everyone is talking about centrifuge enrichment, but let's explore how it actually works. In this visualization, the green dots represent uranium-238 atoms, while the blue dots represent the concentration of uranium-235 atoms. This first batch is natural uranium, which contains only 0.7% of uranium-235. Here, in this image, we have 5% low-enriched uranium, which is used for commercial nuclear power plants. Finally, we have weapons-grade uranium, which contains 90% uranium-235. As you can see, almost all the uranium-238 has been removed, and it is replaced by uranium-235 representing the color blue. Let's show how this is extracted through super simplified animation. The centrifuge consists of a high-grade tube with a spinning motor at the bottom and a feeding tube at the top. Uranium is fed into the centrifuge as a gas called uranium hexafluoride. As the motor spins at high speed, the heavier uranium-238 is separated from the lighter uranium-235 using centrifugal force. The uranium-235 floats to the top and is collected at this section of the centrifuge, while the heavier uranium-238 in the color green falls to the bottom of the centrifuge and the enrichment process is complete. To understand how nuclear bombs are made, let's analyze how Little Boy and Fat Man works in super simplified animations. This is the Fat Man atomic bomb is a large, heavy plutonium imploded using shaped charges as shown in the animations. While Little Boy has a less heavy uranium weapons triggered in a shotgun or gun-type designs. The Little Boy has a length of 10 feet or 3 meters with a diameter of 28 inches 71 centimeters. While the Fat Man has a length of 10 feet or 3.3 meters, but a much larger diameter of 60 inches or 1.5 meters. Comparing this to a person will help you understand its size. Oppenheimer Trinity test marked the inception of the implosion-designed plutonium, eventually leading to the detonation of the Fat Man atomic weapon. The outer charge explodes inward, followed by the inner ring of explosives, creating a concave shockwave. It moves this pusher here, breaking the barren plastic sphere. The shockwaves continue toward the uranium-238. It travels further, compressing the plutonium sphere and compressing it more. Interestingly, this was James Tuck's idea, a British physicist who suggested employing shaped charges as three-dimensional explosive lenses, but it was further developed and perfected by von Neumann, a Hungarian-American mathematician, physicist, and computer scientist. Enough history lessons, let's dive into the basic engineering behind a nuclear weapon. These are the 3 electric gun primers. The primer is the device responsible for initiating the propellant combustion located here, also known as the cordate or conventional charge, that will push this projectile at an explosive force. Moving ahead, this is the projectile tungsten carbide disc. And the most important part is the uranium-235 hollow projectile rings. It weighs around 84 pounds or 38.4 kilograms. While at the front is the uranium target rings that weigh around 56.2 pounds or 25.6 kilograms. That is around 145.5 pounds or 65.5 kilograms of uranium. Closely note, as it is very important to understand, the projectile ring slugs are hollowed and designed for the target rings to enter. All these mechanisms and parts are encased in a 6.5-inch or 170mm smoothbore gun barrel. Moving to the front, this is the impact-absorbing anvil. Just above it is the tungsten carbide plug. These are the 4 polonium initiators placed on the tungsten carbide. They are kept to make sure there will be a nuclear chain reaction when it is dropped and activated. Moving to the top of the structure are the arming and fusing equipment. Let's move outside this atomic bomb to understand it better. These are the barometric sensing ports and manifolds. The barometer helps to identify the altitude at which the bomb is located so that it can activate this Archie fusing radar altimeter. which is these curvy-looking objects that activates before reaching the ground. Just above it is the electric plug, and some refer to this as the arming wires. Step number 1. Before opening the bomb bay doors, all 3 arming plugs are pulled one after the other by the weaponeer William Sterling Deke Parsons. Step number 2. The doors open and the bomb falls due to gravity. Then it switches to its internal 24-volt battery and starts the timer. After 15 seconds, the bomb would be approximately 3,600 feet or 1,100 meters away from the aircraft. Step number 3. The barometer senses the desired height of around 580 meters or 1,900 feet. As the little boy was designed to be an airburst above the ground, the membrane closed a circuit activating the multiple radar altimeters located at the front of the bombs. The barometric stage was added because of a worry that external radar signals might detonate the weapon too early. Step number 4. To ensure accurate detection of final altitude, multiple radar altimeters were utilized. This process involves measuring the altitude above the ground beneath the aircraft or the little boy through the timing of radio waves travel, reflection, and return. Once the correct height was sensed, the firing switch activates. Step number 5. This ignites the 3 Navy gun primers in the breech plug. Step number 6. This sets off the charge consisting of 4 soap powder bags, each containing 2 pounds or 0.9 kilograms of cordite. Step number 7. The uranium projectile will be launched at 300 meters per second toward the opposite end of the gun barrel. Step number 8. 4 polonium initiators placed on the tungsten carbide initiate the nuclear reactions. Step number 9. This is where nuclear fission happens. Let's dive a little bit deeper. The neutron strikes the nucleus and is absorbed. The absorbed neutron causes the nucleus to undergo deformation. The nucleus fission releases an average of 2 or 3 neutrons, thus creating a chain reaction, or in some words, an explosion. The blast radius can be divided into several zones. The central blast zone has a diameter of 0.36 square kilometers, which is the extent of the fireball radius. This is the epicenter and experienced almost total destruction. Severe blast damage zone extends to around 4.5 square kilometers. This has severe damage to buildings, high casualties, and widespread destruction and radiations. Moderate blast zone is about 8.7 square kilometers. Damage to buildings and radiation burn is still significant but less severe. Light damage zone is beyond the blast radius. At 11 square kilometers, here there's fires, radiation exposure, and psychological trauma affected survivors among the thousands. Let's simplify this through these animations. Once the correct height is sensed, the firing switch activates. The 3 Navy gun primers ignite the charge consisting of 4 soap powder bags, each containing 2 pounds or 0.9 kilograms of cordite. The uranium projectile is launched at 300 meters per second. At this point, 4 polonium initiators placed on the tungsten carbide initiate nuclear fission reactions. In a milliseconds, there will be an explosion damaging buildings and killing people by the thousands. We make original animations from scratch with just 3 animators, so please subscribe, like, and comment for more videos.